Using natural light to illuminate the interiors of buildings can significantly reduce both lightning electricity consumption and peak demand for electricity. Since electricity consumption and peak electric demand associated with lighting constitute the major energy operating cost in many commercial and institutional buildings, the potential cost savings of a well-conceived daylighting strategy can be very significant. In addition, there are health and color rendering benefits associated with full spectrum. However, widespread adoption of daylighting techniques has been hampered by the lack of both daylight resource information and simply reliable methods of testing daylighting designs. The benefits of daylighting provide illumination in buildings using natural light as a substitute for electric light. The natural light resource is substantial during most working hours. The light incident on a building is several times greater than that required to illuminate the building interior, indicating that it should be possible to design solar apertures that provide enough interior illumination to offset most or all of the daytime lighting electricity consumption. The luminous efficacy of daylight is generally superior to that of commercially available electric lamps, which means that sunlight has the potential for reducing building cooling loads by replacing electric light of higher heat content. Natural light is plentiful during the hot summer periods, when many utilities experience their peak demand, suggesting that there is a potential for substantially reducing peak electric demand, with consequent demand charge savings for the building owners and reduced capacity requirements for the utility. Natural light is full spectrum light, with significant health and color rendering benefits. Electricity is intrinsically of the more expensive energy sources that we use in buildings and electric lighting fixtures. Electricity is intrinsically one of the more expensive energy sources that we use in buildings and electric lighting fixtures. As is demonstrated by the graphic presented, electricity is intrinsically one of the more expensive energy sources that we use in buildings and electric lighting fixtures. As is demonstrated by the graphic presented below, showing the conversion and transmission losses in taking raw energy at the power plant to usable illumination on the task surface. Daylighting design factors. The potential benefits of using natural light are large. Achieving these benefits is not easy. To begin, it must be understood that using simple windows is not an effective enough approach to take significant advantage of the opportunity. Simply, windows are generally not very effective in providing illumination inside the building for the following reasons. Windows do not necessarily provide significant amounts of daylight in the interior spaces of the building. As a rule of thumb, a simple window can illuminate a distance into the space that is about 1.5 times as great as the distance from the top of the window to the task surface being illuminated. For example, if the top of the window is 6.5 feet above the floor, the task surface is 2.5 feet above the floor, then the daylighting will be effective at a distance of only 1.5. By some rules of thumb, this distance can be stretched to about 10 feet. Lighting concept generation involves the identification of a lighting need and a method for delivering the light to satisfy that need. The concept generation process usually involves starting with a building type or a class of building types. The whole building energy simulations are performed using the detailed building's energy analysis program Energy Plus. The thermal energy trades-off of introducing daylighting can be accounted for on an annual basis by providing the following inputs to Energy Plus. Hour by hour, electric lighting schedules which have accounted for the daylighting benefits in reducing the lighting electricity. The normal hour by hour solar radiation and environmental temperature information required to perform the annual thermal simulations.